That can be soldered like that. Yep, she's ready. I should take the capacitor that we took out and give it the high voltage test, see what kind of leakage there is through it. Could do that. But for sure, these coupling capacitors, that's what this one is. It couples one stage to the next. And it has a pretty hard job to do. And that's blocking the B plus from one stage from reaching the grid of the next stage. And what makes it a tough job is, you know, trying to do that for 35 years or 40 years. That's where it's tough. There we are. Get the little piece of wire out of the radio. This is not a complicated radio, but it still is tricky fishing around inside it here. I have to think about how to get the soldering iron down in there too. Let's see what happens if I get you right in there. Not sure what you're going to see here. It's not gripping the other wire at all. I really don't have them shaped so they can hook. Which is kind of what I want to have happen here. See better on the computer screen than I can with my eyeballs. Gee, you know how you've heard about surgery being done remotely with robotic hands and stuff like that? Gee, I wonder if that day will ever come for me doing this. Seems a little far-fetched. But who knows? Come on there. I'm full fully expect to be doing this in three-dimensional video before too many more years go by. I think it's going to sweep everything. Because it would be a lot better watching this in 3 dimensions, wouldn't it? There is a way to make these 3-dimensional with just a single camera. And that's just to keep the camera moving. I do it because there's a bit of a technique to it, but if it's done right, your perception of 3D is switched on. Because you begin to see the relative positions of things through the movement of the camera. And your brain, that's enough for your brain to start figuring out 3D. Hey, did I get it hooked? No. Come on. It looks different on the screen from what I see with my eyes. That's pretty strange. Now that's hooked. Very lightly hooked, but it's hooked. Let's see if we can get a little solder on that. Here we go. Again, what am I burning? There's a ton of smoke coming up here. What did I burn? Well, that's certainly not one of the better connections I've done, that's for sure. But it's got it. And over here on this end, take a closer look at this. Come on, little camera. Pretty tricky when you got it this close, getting it to focus on the right thing. So this is the other connection here, and that's pretty good too. So you know that's going to do it. Now, should we just go ahead and do the other blocking capacitors? You know, it might just be sensible to go ahead and do them. Let's identify them on here. Maybe we'll do the blocking capacitors. So there's one here, which we just did. Okay, so this stage is connected to this stage via the transformer. There's no blocking capacitor as such. This one's the same way. And all of this is connected through transformers, so there's no way for the high voltage, the DC high voltage, to deliver itself onto a grid here. Let's follow this grid. Oh my, it's going all over the place. Well, another thing we do is we can operate the set and we can look at the voltages on these grids. And the pin number is numbered right on the sheet here. Kinda numbered. Well, the grids are all caps too. Well, that should be easy to do, shouldn't it? Okay, I guess that's what we'll do. We'll flip it over. We're going to operate the set. That gives us a chance to run the high voltage again. Let's do that. Let's put it. Let's give this old capacitor a test and high voltage. You don't have to leak much to cause a problem. That's for sure. So what we're going to do is we're gonna turn up the voltage. We're going to watch the current. We should see nothing on this meter at any time for this guy. Okay, so here we go. Watching the meter now. Cranking up, cranking up, cranking up. Okay, so we just shot 400 volts onto it or so. We did not see a hint of leakage. This isn't a very good test, really. My meter's calibrated for milliamps, and a microamp leakage would be enough to cause difficulties over time. So I think the resistance measurement kind of told the story pretty good. So how can I connect this when I don't have it tipped up? Let's tip it up here. Okay. Put on the supply again. Putting the positive on here, I'm putting the negative. Wow, it's amazing how different a radio can look just because you have it turned a different way. Amazing. Okay, we're going to connect this to the negative point. Oh yeah, we got to hook up the battery again. The 1.5 volt battery. You know, there could be 90 volts on the end of these. There almost certainly is 90 volts on this. I better be a little careful with it. And I think we're ready for a test. Okay, first, without any B+ voltage, switch the set on. Now we're going to turn on the B+ here. We'll watch the meter again. So the voltage is turned down right now. I think I'll leave it down. Turn on. Now, because I'm going to be turning the voltage up, this meter is going to be affected by the way I'm turning it up. I'll try to turn it up kind of quick, but... Okay, so we're up around 90. That's a bit of a higher current. We should be hearing something now. I'd say that's power supply hum coming from the power supplies I'm using. Didn't seem to make any dramatic difference when it comes to that capacitor. Check a couple things. What is the B+ that we're feeding into it right now? 91 volts. And the battery, .2 something. 1.3 probably. So I would say again it's operating poorly. Now we'll do the grids. We'll let's check the grid again on the 1C5. That makes perfect sense to do that, doesn't it? See if what we did helped it out. Down to the grid. Oh, interesting. Very interesting. Let me put this meter where you can see it. Okay, this is the grid we just put the capacitor on. Come on, get on there. Look at that, -4. Now that's the correct biasing on that tube. So I bet you if we just work our way through, we're going to find the next tube also has a biasing problem. Let's see. That's the 1H5. 1H5 right here. It's got a capacitor down here related to the volume control. And who knows what's going on. There's another one of those wafer switches. Look out. Okay. So that might be a problem. Let's check the grid potential on this. It's a cap. And where is that tube? 1H5. 1H5 is... don't jump like that, please, everybody. Stay in your seats. I bumped the camera wire with my knee. Gave you an unexpected ride. So we can just go through all the grid caps here. That's what we can do. Let's do that. Okay, so we're watching the meter. -0.6, that's good. -0.6, that's good. -0.2, okay. -0.6. And look, when I touch the grid, where'd it go? Can you hear that? It's kind of quiet. When I touch the grid of the 1H5, I hear a buzz come out the speaker. And the 1H5 is this guy. When I touch the grid, I can hear some sound coming through out here to the speaker. Not very loud though. No, not that one. C16.00. I don't know what that is. 5. So the problem here is the signal's very, very low. So why don't we try injecting stuff into it? Like we inject some audio into here. And we can also look on this tube, the 1A7, which is the mixer tube. We could look there for the oscillator signal. It should be on pin 6. Pin 6. I believe that's where the oscillator is coming in. Pin 5 would be the radio RF signal coming basically from the antenna. Or is it? Yeah, I think this is all RF. Then into here comes the oscillator into the mixer. So beyond here it's IF. Ding ding, 2 IFs. We should be able to pump an RF signal into the cap of the 1A7. Into the cap. Now this is showing the cap as being this grid way up here. So grid 5, pin 5 is another grid. Let's check that on the 1A7, because there's 2 grids, there's 2 signal grids. 1A7 is in the middle. the middle at the back. 1A7 in the middle at the back, pin 5. What is the voltage? 1A7, middle at the back, that's that one. Pin number 5. Holy smokes. I can't see in there. Okay, there we go. 1, 2, 3, 4. There's pin 5. Pin number 5. That's a minus, that's pretty much a 0, isn't it? I think that ranks as okay. Huh. Okay. Something else I do, which is a bit of a random test, is I look on both sides of a capacitor. I look at the voltage on both sides, just kind of at random. I don't pay attention to where it is in the circuit. I just take a quick look. It's easy to do. Here's one here. I got 90 on one side, 90 on the other. So, that raises a question. What the heck is a capacitor doing with 90 volts on both sides? That's not making a lot of sense. So this guy becomes 0.005 on, he's connected to pin number 567, pin 7 on the 1A7. Pin 7 on the 1A7. Pin 7, what is that? Am I seeing things? That looks like a heater ground. Did I count that wrong? .1A7. 1, 2, 3, 4, 5. Oh, I'm on the wrong tube. Duh. Let's try that again then. That's pin. Oh, really off, wasn't I? Pin. 1, 2, 3, 4. Well, seems to be across 3 and 4. Seems to be across 3 and 4 on 3 and 4. On the 1C5. 3 and 4 on the 1C5. Oh my, look at that. It's right across the... ooh! Okay, well there's a reason why you'd find 90. Where's this capacitor in here? That's it there. Right there it is. 0.005. So you'd find 90 on both sides because here comes the 90 up this line. The 90 DC goes through the coil, comes out on this side, still 90, and heads this way, 90. So that's why you're getting 90 on both sides. So that's probably not a problem capacitor either, because it hasn't been seeing any kind of voltage duty. As far as it's concerned, there's no voltage across it. Yeah, it's possible it's shorted. Really unlikely. We'd have to disconnect it to fully test it. So we'll keep that one in mind, but I really don't think that's a problem. Let's go poking around some more. The best ones are capacitors that one leg goes to ground. Those are ones that normally have a voltage across them. So here's a big one up here. Hey, there's these switches. I haven't switched these switches. I'm trying this radio out. I better do that. I better switch them. Maybe I've got the radio switched in a funny way or something. I don't even know why some of these switches are here. Okay. What? Nothing? What am I on here? I'm on a 1000 volt scale. I should still see something if there's something there. Yeah, I gotta put new pins on my voltmeter leads, which I think I've said a few times. So 0.6 there. Zero there. I should see 0.6 then across it. Okay, not sure what that's telling me. Here's another one. This one, that's this capacitor back here. Hey guys, come on. I'm not falling asleep, falling over. I think that was my elbow that time. Caught the wire. Yeah, so I'm doing this guy here. Ground. That's the other lead. Half a volt. Okay. Let's try this one. This one's also going to ground. Next to nothing there. I don't think I'm getting a good ground connection here on my meter. Zero. The current flow into the radio on the B plus supply is very low now. Very, very low. Almost gone. So did my B plus come off? No? Whatever it is gliding down the whole radio now. If it was too much AVC, which isn't very likely, but if it was, I think we would have seen that in the grid voltages. They would be too negative. They certainly don't seem to be too negative. I could, do the eeny, meeny, miny, mo and start just changing out these capacitors because frankly, I don't know what else to do right at this moment. Let's ponder. Oh yeah, the switches. I was going to try all these switches. See if that doesn't do something. That's probably tone. Yeah, it's still making a little bit of sound. And this is, I don't know what this is. What would this be? What would that be? Oh, let's look at the circuit diagram. No need to sit here and wonder. We can find out. Switch, little switch there. Switch S2 it's called. I don't see any other switches. I wouldn't want to jump to the conclusion that there's an alignment problem so serious that the radio's silent. Yeah, let's try sticking another... Well, you know what? Let's follow the instructions here. That might be a smart idea too. So we go to the grid cap on the 1A7, feed in a 460. Let's see what we get if we do that. Into the grid cap of the 1A7. The 1A7 was the guy in the middle there. That guy. So we'll feed in our our signal. Onto the grid cap. Of the 1A7. Let's put a ground wire on there. Okay, so we're hearing something now. It's kind of neat. We were hearing something. Somebody explain that to me. How come when I put the ground on, it eliminates the signal? That fluttering, I think, is a terrible hum sort of signal that comes when you don't ground your signal generator. It's kind of bizarre, eh? Well, often when I do this, the signal cleans up and comes through loud and clear. Well, you know, it says to isolate the generator away with a capacitor. Let's do that. A 0.06. Come on. 0.06. We'll do it with a 0.05. Show them. Can't imagine this will help, but let's see. We're giving it all it's got here. Okay, take the ground off. Still hear nothing. Get rid of the capacitor. We've lost everything. We've lost everything here. The current flow, B plus current flow, is virtually zero at this point. Why would that be? Because this battery may have just given up the ghost. Let's check it. If the heater battery is not producing enough current, then obviously this is not going to work well. 1.19, 1.2 volts. It's supposed to be 1.5. You know, I think it's still in the range of okay. I'm stuck. How come? I seem to be getting somewhere there for a moment. Okay, the current draw is 0 now on the B+. Now either something's come loose here. Oh! That was I think I shorted it there briefly. Hear that? That's interesting. Lots of signal now. Let's ground this signal generator this time. Look at that. Huh. Okay, let's check the watch this frequency indicator here. Okay, so 460 is where we should hear a nice peak come through. Here we go. I heard two peaks, one at 460 and a second one, 450. Some weird stuff happening in there. That's weird. Okay, well, you know what? The radio's working. Problem seems to be holding up the B+ voltage. I'm not sure why. It went to 0 there. Seems to be back and happy now. With the signal supplied to the 1A7, we're in a position to do second IF trimmers C26T27. So 26 and 27 is the outside can, that's the lower can here. Where are you, can? Ouch. There. Oh, these cans don't come through to the bottom. Yeah, there's two controls on the top, so we need to do an alignment. Must be trimmer capacitors on this one. Yeah, there they are. There's two variable capacitors accessible through the top of the can, as opposed to a variable inductor, which often you have to come in through the bottom of the radio too. Okay, and which one was it's the one at the bottom of the radio. So, well, we'll try a little alignment thing here. Now, I'm guessing you can't hear that. I can though. Okay, here we go. That one was about right. Let me get the screwdriver engaged here. Okay, here we go on this one. There's nothing wrong with those. So that's usually the case with these radios. They continue on to the next one. Just carry on. The only time these things are really out of whack is when somebody's gotten in there and monkeyed around with them. That's been my experience. Okay. You know, I can barely hear the signal anymore myself, so let's turn it up. Oh, that's too high. Okay, now I can hear it. You don't want the test signal very high. You want it as low as you can get it, in fact. And the reason for that is you don't want the AVC to be I think I got a little bit out of that one. A bit of a boost. Here we go. Yeah, a little tiny bit of a boost there. Okay, you really need to do this with a meter too. For a quick check like what I'm doing, your ear is okay, but if you're really aligning something, you really need to use a meter, because you can't hear the, you know, your hearing is not very linear at all. What sounds to you like it's increased a little bit has actually usually increased a lot. For instance, what you hear as a easily audible increase, you know, still low but easily audible, is usually a doubling in the actual sound volume, if you like. And that's what gives us our fantastic range of hearing, where we can hear things so quiet and yet tolerate things so much louder. And we don't know this because it's all kind of automatic in our ears, and you know, it's what we've been listening with all our lives, so we really don't realize it. Eyeballs work the same way, by the way. We have incredibly sensitive vision at low levels, and yet we're able to tolerate this enormous blast of light that's coming from the star. We live so close to the star that we can actually see its dimensions. But we have no sensation. We go in and out of our houses from inside to outside, and the amount of light is varying by millions of times, but we hardly notice it. So, hats off to biology. Well, enough of that talk. Well, I'm not sure what to do with this any further here at the moment. It's weak. I think I'm going to ponder the situation for a little bit before I carry on, and I got a whole bunch of stuff waiting here to be worked on too, so I might even set this guy aside while I ponder it and go on with something else. So thanks for watching. Sorry we haven't really nailed down what's going on with this radio yet, but persistence will pay off. It always does. I'll see you next time.